Sorry. Hi, welcome on my presentation. I would like to present you 1 year of our trial of sandboxing-based system with Capsicum. I will show you a lot of examples how we managed to accomplish that and what are downsides of Capsicum. And yeah, so my name is Mariusz Zaborski. I'm working for Wheel Systems company. We are doing a few interesting products to monitor network traffic and to monitor administrator sessions and to decrypt TLS traffic. So if you're interested in any of those products, please go and visit our website. I'm also a FreeBSD developer. I'm still getting into this project, but I'm very excited to be here second time at this conference. Okay, so first we will start describing what is Capsicum. Then I will tell you a little bit about how to sandbox using Capsicum, and then I also show you Casper daemon, so the daemon that helps you with Capsicum. Okay, so Capsicum provides you two main things. First is the very tight sandbox in which you cannot do almost anything. You can use only the rights, only use capabilities that you already have. And second one are capability rights. So in Capsicum we are almost everything do on descriptors, and we can limit those descriptors even further to do only precise thing that this descriptor is created for. So if the descriptor is created read-only, then it should be used read-only. So, like I mentioned, after entering the capability mode, we don't have access to any global namespace. So we cannot open any files, we cannot manipulate with time, with jails, we cannot do, we cannot access any of those namespaces. Of course, we can manipulate with the namespace, I call it local namespace, which we already have. So, for example, if we have a descriptor to catalog, then we can open any file in this descriptor. If we have a connection to other process, then this process can provide us additional capabilities. So this process can send us, for example, descriptor to the file or to directory. So, as I mentioned before, we have also capability rights, so we can limit the descriptors even further. We can say that this descriptor, we can read only from this descriptor, or we can write only to this descriptor. We cannot extend those rights. We cannot say that, yeah, this descriptor was read-only, now let's do it also write-only. And if any of the process that we are connected to will send us some descriptor, we cannot expand by ourselves those rights. Here we have a few of those rights. For me, very interested is cap append, which is very useful, for example, for processes that are logging some stuff to our system. So if we have a descriptor which is append only, then we can only append additional logs to this file. So if, for example, attacker would break into our process, he cannot overwrite any existing logs in this file. So it's very handy for security reasons. So is capsicumizing hard? Of course, if we are doing new programs, when we are creating new applications, it's very easy for us to create architecture that will fit almost any sandbox techniques that we already have. So it's very easy for us to create new programs that are fit in capability ideology. But the question is it easy to capsicumize already existing application? So in 2015, we have, until 2015, we have a few applications which was using Capsicum. It was nice. We have like KDump or TCP-dump. Those are very interesting program to Capsicumize, but still, we have only few of them. We put a lot of efforts in last year, and we was able to extend the size of amount of the Capsicumized program. So we have a lot of interesting programs like traceroute or Beehive or Decrypt Core or even packages using Capsicum. So yes, or how George mentioned earlier on his presentation, we also sandbox yes. So he stole me my joke. So how we went from 2015 to 2016. So the thing was very small. There was a bug in VS patch which was very trivial. We just had an integer overflow, and this allowed us to run arbitrary code. So and we fixed that bug, but then it turns out that we fixed it in the wrong way. So there was another vulnerability in that program. So one of FreeBSD developers, Alan Judd, thinks, how hard it could be to sandbox VS patch. So he went and started reading code. So do you see write the code? Because there will be a lot of code, so I hope it's fine. Okay. So we need to read code. We need to understand what program is doing, what this program is capable of. So this is, of course, a little bit truncated code of VS5, but we can see a few things. And the most important things for us are things that are not allowed in capability mode. So, for example, opening the files. All of the openings in Capsicum are forbidden, so we cannot open arbitrary file in capability mode. So Alan moved all of opens just before entering the capability mode. So his patch was very simple: move all the files, all the opening files before entering capability mode, and this is for us. Enter is basically like barrier. Like after this, it's done. You cannot do anything more with any global namespace. So basically we could put cap enter here and we are done, sandbox is done. But Capsicum allows us to go a little bit further, and we can see here that every of those descriptors are used in some particular ways. So for example, we read data from those descriptors, or we fseek on those descriptors, but we never write to those descriptors, or we never change mode of those descriptors. So we not only add the syscall that allows you to, we not only enter the capability mode, but we also limit every descriptors only to be read and to allow things. If we were to read a code more, because like I mentioned, this was only the truncated version of the code, we would see that there was one descriptor which was also had permission to write, and the fstat also was done on those descriptors. So those are two additional capability mode which needed to be provided for those descriptors. So that was quite easy, and we was able to capsicumize program, and we are now more secure. We are even if we would have more buffer overflows or integer overflows in that application, we are more or less secure. So we decided to go further. Maybe we can go and capsicumize more applications. So for example, CMP, which just compares to files. And this is a patch which do that. It's easily sets some rights on the descriptors, FSNTL, FStat, and MMAP. Then he limits two descriptors, limits FS and the Ls which are allowed in this descriptor, and enter capability mode, which unfortunately didn't fit in the slide. So that was nice, but we saw that we have like very code which would be repeated in different parts, in different programs that we want to sandbox. For example, because we don't have access to, because we want to limit, for example, std_in, std_er in our sandboxing program, then we would need to put all those 5-6 lines in every code to just limit the standard input and output. So maybe we can do something more with that. Maybe we don't need to every time go and copy-paste the same lines of codes. And also here is a very specific thing for Capsicum. Because we cannot open any data after entering capability mode, we cannot open some files. Every file needs to be pre-opened before entering the capability mode. So, for example, we would like to have native language support in our application, but we need to open every file which is connected to that before entering the capability mode. So, for example, such thing like cat open libc must be done before entering the capability mode. This is also very tricky because how a programmer need to know that cat open is something that he should or should not open? It's not very obvious for him. So we created something called Capsicum helpers. It's very small header with few inlines functions. Those functions are used to sandbox to limit code which is used to limit the standard streams function. So we have a very generic function called cap_h_limit stream, which can limit any descriptor with standard flags and standard capabilities. And we have three functions that limit us just std_out, std_er, and std_in with standard things that you would like to do with those descriptors. Unfortunately, in Capsicum, libc isn't very friendly for Capsicum because he often opens some random files or access some random global namespaces. And this is a little bit tricky, unfortunately, because, like I mentioned, error, which prints some error message print some error message, or local time, access random files, maybe not random, but access particular file on the disk to cache some data. It's done only once before when you run this function, but you need to know that those functions do that. If not, then they will fail, or they will not do proper waves. For example, we will not have translation in error messages, or we will don't fetch right time zone, so also would be a problem for us. The same thing is with syslog, which this is a very, very tricky set of functions, because syslog functions try to connect to the syslog daemon, but if they fail, they will try to connect every single time. So those functions are very tricky on libc, and I still didn't find any right solution for those. We also had a very tricky ways with dynamic shared objects in Capsicum. So if I remember correctly, there was a function called get time of a day which was using those, and if this function would fail, then we would go back to using just syscalls. So we also would need to have some caching before entering the capability mode. So we also extended the Capsicum helpers and add few additional functions called cat pages and tz data. Cat pages is doing the NLS caching for us, and tz data get all the time zones data which we need to use in our program. So it's very good also for developers, because we have all documentation that we need to know before entering the capability mode. So instead of having very duplicated code, which I showed you before, we can just use the cap-h functions to limit the code that we need to write in our application. So we also add some debugging infrastructure recently in Capsicum, for Capsicum particularly. So we had before key trace and key dump, which allowed us to see every syscalls that was done in the program. It was very nice. We had every error that occurred in our application, so we could, for example, see that there are some random opens in our programs. Maybe we can somehow fix them, or we missed some places. So we had information about that. Unfortunately, it's very easy to miss something using cat trace, and it's very hard to cover all paths which are used by your program, because you need to run with it with different arguments, with different flags, and so on. So here we have, for example, example of cat race, where the open at failed because we are already in capability mode, and open was not allowed for this function in this program. So it's very easy to miss this. It's not permitted in capability mode. So we propose a new method of debugging. So we add the sysctl kernel trap anode cap, which sends when it's set to on, it's every time when something is done which shouldn't be done in capability mode, we will get seek trap. So there will be created core dump for our application, and we can analyze what's happened in that application, what was the trace of this application. We can also set this this flag only for a particular process with process.ctl, and it's very easy it's very hard now to miss such unallowed function, unallowed syscall, but it's still hard to perform to cover all paths. So if, for example, some libc functions open some random files in very particular cases, then we probably still will unfortunately miss that. So here we have a program, exactly the same program, which just failed because he couldn't open some files, and we have now backtrace of this file, and we can analyze what's happened. So we also provide some mechanisms which should allow you to capsicumize much easier. One of them is Casper D. Sorry, it's Sleep Casper. I misspelled it. So Casper allows you to gives you all the functions, maybe not all, some of the functions which are not allowed in capability mode. So for example, if you want to get DNS, you want to resolve some DNS name, this is forbidden in capability mode. But using Casper, you will be able to do that. So it was created to make capsicumizing much easier. We need to create all the services which we want before entering the capability mode. And while we will call the function from Casper, libcasper, then we will create such called zygota, which can be transformed in any services that we would like. So we can open only one Casper. We can only create one Casper process, and then we can create more services from it. Now we are providing a few services, like I mentioned before, for example, DNS service, or we provide functions that you can get all the DNS resolution which you want, or for example, random function which allow you to obtain random numbers in a secure way that you don't need to pre-cache any data. So we, for example, capsicumize traceroute using a Casper as well. So here we have a sample patch. We first call cap_init to create a Casper instance. Then we open services which we want, for example, system DNS. And then we limit this system even further to only resolve names and address. And we limit this service to work on IPv6 only in IPv4. And now we can do our normal stuff, which we already know. So we can limit our descriptors that we have. So, for example, the descriptor to server, which we created, and we can enter the capability mode. Next step, unfortunately, is we need to replace all calls from getHostByName, which was called originally, to use the Casper daemon instead. So we have exactly the same infrastructure, the same arguments passed to getHostByName, passed to cap getHostByName, and also we need to provide the Casper connection for this function. This is the first argument, cap DNS. I would like to thank few people who made it possible to sandbox so many applications in base system. It's Alan, Baptiste, Konrad, Ed, and Konstantin. Konstantin was working on provides new infrastructure for sandboxing, for debugging our applications. Okay, so thank you very much. Do you have any questions? Yes?
I have one question about the Zygota, the thing that you use in order to obtain, well, to call services that you shouldn't be allowed to use in Capsicum mode.
Yes.
Isn't there the risk that there's some bug in there and that you can actually get more from it than you are supposed to do?
So the question is that, is there any chance that there will be some bugs in the Casper services and we will be able to obtain more rights than we supposed to? So yes, there is such chance, but all the reasons why we try to do is to reduce the amount of code which you need to trust. So now you need to trust only the Casper service and IPC between the Casper service and the program, right? And normally you would need to trust whole the application and everything around this application that it will work. So it's reduce the amount of the code which you need to trust in that case. So yes, of course there is such chance, but everything is about the reducing of the TCP of application. So is there any more questions?
Yes. What kind of privilege can Casper have?
So, right, what privilege does Casper have, right? So, Casper is started before entering the capability mode, so he is not sandboxed right now at all. We can limit Casper in some cases, like using different methods than Capsicum, and yeah.
Same privilege as the original application.
Yes, Casper had exactly the same privilege like original application.
It's not root privilege.
No. Before, when we had a daemon which was a Casper, then it was a special user Casper D, from which the Casper was running. But right now, it's a normal, exactly the same privilege like original application from which was formed.
How early is Casper D started when the system boots?
So, like I mentioned, this in previous implementation we had Casper D, but now we resigned from it. Now it's just a lib Casper which just fork original process. This makes us much easier in many cases. For example, the current working directory is the same max labels are the same. We didn't need to care all of those things. When it was a daemon, then we would need to pass a lot of data to this daemon to have exactly the same rights which process has, because you don't want to extend those rights, right? So, yeah.
So my question was, how early in the boot process can you make use of this?
How
the process be? Because I thought it was a daemon which would need to be running, but if it's a library.
Yeah, you can run as long after when init D is started, right? You can just fork another process, so you can do it whenever you want, basically. When you can just from the first process after init D, you can use Casper.
And how is the communication between these processes done?
So it's done by Unix zoning sockets. So you just have a socket in your original application. It's a little bit more complicated. We create structure for that, but one of the fields in the structure, it does the descriptor to the services, and you send simple commands to these services like resolve me that, or give me random number, or something like that.
Do you have shells which are using this? Can you limit user shells and other complex programs like that?
So the question was, do we have shells which are using Casper or shells which are using Capsicum? I guess at all. So there are some works done by Jonathan Anderson, but we still working on that. Basically, if we would have, because one of the things which we still very missing, and it's unfortunately my fault, is a service for Casper to file systems, which you can say, open me that file, open me like something like that, right? So then I think we would be able to do something like shell for using Casper. But because we are missing still the service, for file system, it's basically the main problem.
Well, for a shell, you need to execute the binary as well, and you cannot load.
You can just fork, and you can do at the exec, right? In Capsicum.
But you cannot load you cannot deloop and everything in that case. So you can do that for static binaries on their own.
Yes, it would be much more complicated because in Capsicum, when you fork and you exec, you don't lose samples, right? So you would need, the application would need to be aware of that. So every time, for example, if this application would want to open some file, this application would need to have a connection to Casper daemon to do that again, right? So every application run in this sandbox will be automatically sandboxed. In this shell will be automatically sandboxed, right? So every application run in this shell needs to be connected somehow to Casper.
So the daemon is still there? I thought you said it was just a library.
It is, sorry. So it's not daemon. When I mean, because when you run Casper, you fork, you create a new process. So this
is what you call the daemon?
Yes. Sorry, I was referring to this new process that is Casper. So it's not a daemon, it's just a process that serves you all your data which you need. So yeah.
How much time do you need on average to work on an application to make it use Capsicum? Like a simple application like, say, traceroute?
Yes, so this is very, very good question. Like any application which didn't need access to file system, because the file system is the biggest problem for us. If application opens any random files in the system, then you need Casper. So unfortunately, right now we are not able to sample those applications. But like KDAM or something like this, it depends on how complex is this program, because you need to understand what it's doing and what you need to provide this program, right? So besides that, it's like a couple of lines you need to actually write, or even if it's fixed number of files which it's open or not, you just need to move them around, and that's all. But in case of more complex programs which are using random files, we need Casper daemon, Casper file system. So yeah. Yes, and it's still in progress, unfortunately. Yes?
Yeah, for writing portable programs that use system resources like get outer info or get host by name or whatever, will I have to do cap underscore and then the name of that service as well as Casper for all of these?
So this is a very good question as well. I have an example here. So if you have like libcasper, you have like ifdef for that. We are now also working to remove this ifdef and provide you with, for example, inline or something like that function, which will detect for you if you have Casper or not. So if you have like program which don't like operating system which don't support Casper, you just will have like simple library or simple inline simple header which will just call standard get host by name. Yes?
Do you think you would be able to use a Capsicum or make use of Capsicum in a program during the time frame of your presentation? Like if you had started out with the presentation by starting with an uncapsicum program, would you now be at the stage where the program was signed?
It depends on the program, but yeah, you know, if you would choose for me, yes, then you know.
So I set myself a challenge and I pledged MTR, you know, my trace route.
Excuse me, what?
You know my trace route, the tool that brings a route.
Yeah.
You just pledged this during your talk.
Okay.
So it was just for me to see, and I never used pledge before. It was like the first thing I tried. And I think it works. It still has quite a lot of things, like you can't read files. I don't know how to get rid of that yet. But it was surprisingly okay. And I had to add like 3 or 4 lines. So I was quite happy with that.
I can synchronize the diffs through binary during the talk.
So, you see, it's depending, right?
Once you get used to it, it's very quick with some people.
Yes, I understand now the pledge argument instead using pledge instead of Capsicum, right? So I made a presentation last year about comparing pledge and Capsicum and Seccom as well. So in my private opinion, if pledge is very fine sandbox mechanism for simple programs. Like example WC, which we struggle a lot. Like you just say, okay, you have read-only access to your data, and that's all. You don't have access to any other things in your operating system. You cannot create connections. You cannot do DNS resolving, whatever, right? You can't. WC, count me my lines. Access, read-only access to my data, great. But when we go more complex, then pledge starts to be a little bit sloppy in few things. For example, if you have a program which needs to read some data and need to create some connections, then you need to give it access to those 2 namespaces. So this is not stopping me for creating like random connection to the server and send any file from my desktop, right? And in Capsicum, I agree, it's a little bit more complicated to sandbox the application, but you cannot do it in wrong way. Basically, you need to do it properly. When you sandbox using Capsicum, you're in 100% sure that it will not happen ever, right? I cannot create any random connection. I cannot create open random file in the disk. So you will not have this problem.
So it's more fine-grained.
It's more fine-grained, exactly. And and if because there are some few of the programs which try to do pledge in right way, like I described it. You don't want those 2 permissions in pledge, for example, together. Then they do exactly that. They fork. They have one process which can do connections, and another which can read data, right? So why not use then Capsicum? Because you did the hardest part already, right? In separating the process.
Yeah, but that's already done. So if you already have it separated, then
yes,
if you game and using the library that was used for it.
If it's already, if it's already separated, you don't even want Casper then. You just, limit one process, right, which is potentially more painful, right, which can have more bugs, and leave the process which don't have, which, send, for example, only files. Like, okay, get this file, I don't know, verify the signature, which, use OpenSSL. I don't want to use OpenSSL outside Sandbox, and return me the message which say, okay, it's done, it's not done. You can do the same with pledge. Limit it only to read and leave read and connection in the master process, but, if it's still a problem in many cases. Maybe not problem in many cases, but what I was trying to say is, in this particular situation, it's better to use something that don't allow you to make mistake. Because if I will leave some extra permissions or I use wrong permissions together, then I have a security hole. Which, like I mentioned, if I can read file and create connection, I can push my files outside the internet. outside my computer. Or if I, for example, leave the exec permissions and I leave the fork permissions, and somehow my master process will be hacked, right? Or not, even not master process, because we don't have separation. But I leave those two flags, and I can run arbitrary binary. So why this binary will not create me a connection to the server, right?
So the idea there is that a lot of binaries are using pledge and are limiting what these binaries can do, and the assumption is that because everything uses these sandboxing tools, the tool that's being run will actually know how to restrict it.
Okay, but if I have like, okay.
I mean, if you can run arbitrary code as a user, you can run arbitrary code, of course, but as long as the programs called also use pledge, then that's not.
It is, because, for example, I can run NC. NC is sandboxed, right? But I can push every data which I want from your application. I only have read access on your disk, and I can fork and exec. Then I run application which will do exactly task which I need. So, for example, push my data outside your system. There was some question.
Yeah. So I'm not that concerned with which is better, because as somebody who writes portable programs, it doesn't matter. I think that one thing that I'm concerned with is that the way that Capsicum works is different enough from existing capability systems that it presents a challenge for writing the same code and making it portable between these. For example, if I'm cursed with using seccomp, and I have them, and it's not pretty, or systrace, which I also use a lot. The way that we use those is basically the same as how we use pledge. But with Capsicum, the difference, or the concern rather, is how hard is it going to be to not restructure the program, because generally they will be written that way already to open resources and then play. But actually, this kind of group right here is what concerns me, because that means that I have to audit the source code to find all of the instances where it's doing this kind of thing, instead of having, as you mentioned, like a nice inline function. So what are you or the other previous people doing to make it easier for people like me to actually use Capsicum? Because we want to.
Yes.
But there are some challenges right now. For example, how do we use Casper if we're in churros? Because that socket won't be there.
So basically, you run the Casper before entering the chroot, and he will have this access,
But
right?
what if we're already in a churros when we start?
But you would like to have Casper as soon as you start the program, right? So you can do like set quit or set git and then start the Casper to have exactly the same rights and leave it before entering the chroot.
So let me ask a specific question, because this is the one that is bothering me right now. So I do a lot of CGI stuff, fast CGI, and we're already churooted in that case. So we don't have a chance to do anything. We're already in www. Thank you. Is there any way, and this is more a question on I think it can be done, I'm just curious how, to make it as easy as possible for me to write programs such that I'm guaranteed that they will be running with this extra security. And I know that with something like Pledge I can do that because it's in the kernel itself, but if I start to depend upon libraries
But if you will enter the chroot, then you will still don't have access to this. Because I understand you want to connect to the Unix domain socket?
Yeah, the question is, if I'm in the CGI scripts, it's started by the web server, it's already privilege dropped, I'm already chrooted when it begins. So if the lead Casper, socket or whatever is there, then great. But the question to me is, it doesn't seem very easy to port programs, CGI scripts at least, safely to lib Casper and Capsicum if I can't make guarantees as to as to the existence of a socket or something like that.
But, okay.
I think in that particular case, the CGI is built statically, right?
Yes. Yes.
So in that particular case, the CGI is statically linked. So it will fork itself and create itself a socket. It's not expecting a socket which is outside of the shroot. And so Casper will run inside the shroot.
So it will be there, or it will be the same, exactly the same situation in Pledge. If you want to connect to the socket which is outside the chroot, you will fail because you don't have access. But if you will be chrooted and you then do create a Casper and you want to get the socket which is in this chrooted environment, then no problem. And then you start in CGI, just have enter.
Yeah, so basically it's just a library. It's just a library that will be linked like your KCGI, for example. Yeah.
So yes, going further, because you started another topic that you don't like seccomp and Pledge is better because all of you those are do it easier, right? But I get a feeling, it's again my private feeling, that the difference between Pledge and seccomp is that you just have predefined rules, right? You can implement Pledge based on seccomp because it just gives you the predefined rules what you can do or what you cannot do. So yeah, so are there any questions? Okay, so thank you very much.